For this lesson, we're going to introduce common logs and natural logs. These are logs that have bases that we can use shorthand, less notation in order to list the log. And so I want to introduce that notation in this lesson. So first of all, we want to note that the common log, the common base we use in our number system is base 10. We use 10 quite a bit. And so when we do that, when we look at a log, if we list a log without a base, notice that there's no base listed there. You know, the assumption for exponents, if you don't list an exponent, is that it's 1. The assumption is when you do a root, like you have a root and there's no index listed, it's a 2. When there's no base listed for a log, it's base 10. So we have to get used to this idea that if we neglect to put a base there, which is common practice, to oftentimes use a base, a log without a base, that means it's going to be base 10. And when we look at our calculator, if you look at your calculator buttons here, there's a log button right there that has no base on it. That is log base 10. Just so we're clear on what that is. So be aware that there is a log button, and that means that it's base 10 when we see that. All right, so examples to do, let's just see what we've got on our calculator. If I want to do log of 10,000, let's go ahead and look at our calculator here. So if I look at hit log and put in 10,000, okay, that's going to be log base 10. 10 to what power equals 10,000? That's what this is asking. Remember, the answer to a log is an exponent, so you got to think ahead. 10 to what power is going to be the 10,000? That will be our answer, and the answer is 4. Now, if you remember, when we've done exponents before, 10 to a power, you just count the zeros. 1, 2, 3, 4. There's 4 zeros there. That means that the decimal's been moved 4 times to get to that point there. That's our answer to it. So without a calculator, when you're doing a common log, you just count the zeros on a number larger than 1. All right, let's look at this one. This one we got it without a calculator would be counting backwards on the decimal plate, the decimal point. How many times do you move it to the negative direction to get it past there? Well, you move it 1, 2, 3 times. So this answer without a calculator should be -3. Let's check it out on our calculator. Let's do log of 0.001. Okay, so we've got our 2 zeros and a 1 on that. Okay, when we do that, we get an answer of -3. So the calculator key can do this log base 10 for us. All right, now let's do the last one here. This one, log of 105, you got to understand that this one has to be done with a calculator because 10 to a power, we get 10 squared would be equal to 100, 10 cubed would be 1,000. It's going to be somewhere between 2 and 3. And so when we do this one, we're going to do it just with a calculator. So log of 105, and we get the answer to be 2.02, and it goes on from there. So I'll do it to the hundreds place. So about 2.02. So be aware that this means basically 10 to the 2.02 power, and it keeps going, remember. So to get it exact, you have to give more decimal places. It's going to equal 105. All right, you can try that out to check it out, but we've rounded it to 202. Now there's one more log key that we use, and another one that we have a shorthand version for where we take out the base on, and this is the natural log. Natural log is usually listed as an L and an N. So remember, this isn't the letter L, this is an N. It's like natural log backwards, log natural. Okay, that's where the L comes from. So when we have natural log of x, that means we're going to have base E. So notice how this one is very much a shorthand problem, because instead of writing out this entire statement, you just have to write natural log, the ln of x, and that gives you base E. Now you might wonder why we would introduce base E, because this is new to most Algebra 2 students, and so you have to recognize that E will become used more and more in mathematics following this, and so we need to introduce how we're going to use it in future courses by introducing it here. The calculator key has an L and an N on it. It uses the capital letters when we do it. So if you look at this calculator, underneath the log is an LN key. That's the natural log key. So if we're going with a problem like this, where we're gonna do some problems with natural logs, let's go ahead and remember what some of our conversions are. So when we do this one, if we were to convert this into a log, remember what you would do is you go log base E, so we start here, of x is equal to 3. Okay, that's how we would write that when it comes to writing out the log with the base. Well, we can do this as shorthand and write it just as natural log of x equals 3 instead of doing the whole log base E. It will be the shorthand version of doing that. Let's do the next one on the calculator. We're going to do 6 plus the natural log of 8. So let's practice using our calculator for this. Clear these off. So we're going to go 6 plus the natural log of 8. Let's see what that gives us. Okay, that gives us 8.079. So we'll round that to maybe 8. We'll just do 8.08. So approximately 8.08 as an answer. It goes on forever, so remember that the decimal goes on, but the answer to this gives us, notice that if we were to look at this and subtract 6, it would give us the answer to the natural log part of it. The natural log of 8 would just be 2.08, or the extended decimal, right? So there's our answer for using the calculator. Let's solve some equations using these by converting. Okay, so we're going to convert this one to an exponential, and so when we do this one, we get do our circle tour. So we can go 4 squared is equal to the inside part, 2x minus 3. Okay, so just a reminder, just a practice problem of converting this one. And so we get 16 equals 2x minus 3. Add 3 to both sides, you get 19 equals 2x. And then divide by 2, and you get x equal to 19 halves for an answer. And when you look back at this one, if you put 19 halves back into this, you do not get a negative or 0, so it does check. So this is our answer. So this isn't converting to one of our new log problems. This is just a review of doing our conversions. But if we were to do this one using a conversion, okay, now this one will involve one of our new log notations. Divide both sides by 3 to get e to the x equal to 10. Now I can do my circle tour, and so we get log base e of 10 is equal to x. You might say, well, what is that answer? Well, we can now do it on our calculator, because log base e is natural log of 10 is equal to x. So this conversion, we can actually use a calculator key for and do the natural log of 10 and get an answer to it of 2.30, etc. So rounded to 2.3. So this is approximately 2.3 for an answer. Okay? Now, what we have to remember on these is that we've introduced 2 new notations. We've introduced the idea of if there's no base listed on a log problem, it's implied to be base 10, because that's the common base we use in our number system. We're a base 10 number system, so base 10 is the one that we assume when it's not listed. If we have instead this notation with an ln, natural log, that's base e. So we have to remember now we're connecting that to our irrational number e in this log notation. So using these two log notations is going to connect us to our calculator where we'll be able to do more calculations in the future.